Hello everyone, my name is Ria Jamnadas and I would like to welcome you to this webinar where we will be discussing the topic of whether clean energy is critical to the success of 5G. So welcome to all of our listeners. Before I introduce our presenters and panelists, I'd just like to run through some logistics. So firstly, you're all in listen only mode. Should you need to contact us during the webinar, please just type a comment using the icon that you can see shown in the image on the left and we'll do our best to sort out any issues. We do also encourage you as we go through this webinar to drop any questions that you might have for our panel in the chat box as well. And again, we'll do our best to respond to your questions during the live Q&A session at the end. But for those questions that we're not able to answer during this live session, we will get back to you with a summary following the webinar. And also just to let you know that after the live session has ended, we will follow up shortly with a recording and also the accompanying slide presentation that you'll see today. And finally, please do tweet and encourage others to join and listen in. Now, I would like to introduce our panel. So as I said, I am Ria Jamnadas. I am a consultant at STL Partners and I will be moderating the webinar today. Also from STL Partners, we have Phil Laidler. Phil is a consulting director and also a partner at STL Partners, and he will be doing a presentation for us shortly. We also have my colleague Matt Bamforth, who is a consultant at STL and will be joining the panel discussion and Q&A. We also have Danny Wong from Virtiv, who is Senior Director for Telecoms Asia. And we're also delighted to welcome Yusheng Li and John Wang from the China Mobile Group Design Institute. Yusheng is a senior architect and John is a consulting engineer. A quick run through of the agenda for today's discussion. So firstly, we'll be hearing a presentation from Phil on the 5G energy emissions challenge. So Phil will be touching on some of the kind of key findings from our recent research that we've done. Then we'll be hearing from Danny on the 5G Deployment Balancing Act. And next we will have the panel and Q&A discussion. So without further ado, I'd like to hand over to my colleague Phil, who will kick off with a presentation introducing the 5G Energy Emissions Challenge. Over to you, Phil.
Thank you, Ria, and good morning, good afternoon to you joining us from Asia. This presentation is going to, just click the next slide, it's going to actually be a quick run through of a report that we recently published with Virtiv. And this report really sets out why energy management is critical to 5G success and sets out a framework we think that operators should be looking to adopt for driving their own use of energy management within 5G networks, but also the opportunity for them to engage their customers. So I encourage you to download this report. This report was on the back of some interviews and a survey of 500 enterprises globally, and you can go to the Virtiv.com site to download the full report in English or a shortened version in a group of languages that are listed here. So those of you who find this interesting, please go and take a look at the full report. I'm going to run through this very quickly in the next few slides. So first of all, taking a little bit of a step back, we at STL believe that telecoms is reaching a new age. And the way we talk about this is we talk about the first wave of telecommunications, which was what we call the communications age. And that was really about individuals communicating at a distance, initially with telegraphy and then with telephony. So it was really about overcoming distance and real-time communication between individuals. And that's over 100 years old. Then came what we call the information age. And that was much more about providing access to content and reducing transaction costs. So that's really been highlighted by the mass appropriation and the mass appeal of smartphones and the internet. We now think that telecommunications is entering a new age, which we're calling the coordination age. And in this age, the challenge isn't so much access or remote communications, it's much more resource availability, efficiency and conservation. And this is much more about connecting many things, not just individuals to each other and to content, but it's about connecting that, and it's about automating, and it's about coordinating the world around us for better resource outcomes. And as we move through the age, so has the value. So we would argue that operators have seen they continue to support communications and they will continue to support the information age, but a lot more of the value from the networks is moving up the stack to coordination age. and that there is a need for operators to define a new role beyond just connectivity, to play a bigger role in that coordination age. At the same time, go to the next slide, we know that the world, our planet, is facing more and more demands, facing more demands in terms of availability and access to employment, healthcare, access to capital, to education, also increasing demands on greater efficiency of the resources we have and conserving the resources we have. So we, as a sort of at a planet level, we have these big challenges, and everyone is fully aware of the challenges in terms of sustainability, climate change, and managing waste. So this is becoming the new global challenge that we need to meet. That's the background and framework. Now, that's the framework for 5G. So the next slide, 5G was really conceived for this coordination age. Apart from the characteristics we list here, latency, bandwidth, capacity, reliability, critically, 5G is also the underlying architecture is very different for the technology. It's much more programmable, it's much more virtualized, it's much more agile, it's adopted cloud native business practices. So essentially, the intention with 5G isn't that it's just a one generation thing, it's as a continuous evolution, and it's designed to follow this agile evolution, continuous development, and meet these very, these demands of the coordination age. So 5G is very much conceived to fit into the challenges that we set out before. And go to the next slide. The expectation is that 5G globally, and some countries are ahead of others, but globally 5G is driving much of the growth. And we would expect that by about 2025, 5G will be overtaking in terms of traffic volumes the existing 3G and 4G networks globally. And by 2027, the networking capacity or traffic added from 26 to 27 on 5G will be equal to the current total traffic on the 4G networks. So with this provision of the 5G networks, there's a huge demand in all of these connections. All of this coordination is going to require a massive increase in capacity, and that's part of the challenge we have, because as well as wanting to support the coordination age, we have to do that in a way that itself is efficient and energy efficient and doesn't generate more emissions for the planet. And that gets us to our key challenge, our energy challenge. On the left-hand side, we see some real positive things that 5G can help to curb excess energy use. It is fundamentally more efficient. It's about 90% more efficient than 4G at a unit level, unit of data transmission. It has more elasticity. We've seen it's a cloud native, so it's able to turn off and turn down. You don't have to leave it on the whole time. You can put it to sleep when it's not needed. So it's a lot more elastic. The virtualization I mentioned means that there are faster continuous renewal cycles. So there's an ability to continuously update and upgrade the software and the hardware in a much more continuous manner than the previous generations of technology. And there's also more opportunity to share resources between operator, and potentially there's the opportunity to decommission some of the older networks and therefore remove them and the energy demand associated to them. So that's on the plus side. On the negative side, on the other side though, there are some challenges. We've just seen big growth in traffic expected, and as more capabilities are introduced with 5G, so the traffic will increase. Coverage, because of the higher spectrum, coverage means many more cell sites need to be provided to achieve the same levels of coverage. That also represents a potential burden on energy use. And this cloud native infrastructure, if and where it's adopted, it requires almost data center-like environments, and with that comes the demands of cooling and of uninterrupted power supplies. What's more, these data centers are going to be housed in much smaller distributed edge data centers, which that represents another logistical challenges. So there is a balancing act here that has to be achieved in, yes, great potential savings in energy, but some real challenges in how it's rolled out. Now, the next slide, we sort of set out essentially, 5G is coinciding with a decade of huge transition globally, particularly in terms of transition in energy and the move to more renewables and the move to reduce carbon. And that is these two things are happening at the same time. We're rolling out our 5G networks, and at the same time, we are, as a planet, we are trying to move away from fossil fuels to lower carbon, and we're trying to reduce our emissions. So it's no coincidence that this is going to put pressure on 5G. We expect that from regulatory and from advocacy groups who are going to be pushing for operators to reduce their carbon footprint. Also, we expect to see pressures from costs, because not only are there significant costs associated with the energy, but there's lots of other costs associated with high energy, lots of truck rolls and additional investments. And importantly, other stakeholders, from the customers, from investors, from employees, they will be putting pressure on operators to minimize the energy use and minimize the emissions from their 5G networks. So big challenges for the 5G networks. At the same time as rolling them out, there's a lot of focus, there's a lot of pressure for operators to do more in terms of their own energy use. But we actually see this as an opportunity. And our key thesis in this report here on the next slide is that rather than seeing the energy challenge as a barrier or a constraint, operators can see it as an opportunity. By implementing best practice in their own 5G networks, they can bring insight and credibility to their own customers who are also trying to drive efficiency and change across all range of industries. And they may not be doing that primarily for reasons of energy efficiency, but they will be looking for best practice in terms of automation, efficiency, and managing of their service. And that in itself, that credibility and insight, will allow them to address new revenues and drive that revenue growth. And that learning as well will help to support the best practice in the networks. So we actually see this as an opportunity to introduce a virtuous cycle by focusing on best practice and at the same time bringing that insight and credibility to their own customers to helping them optimize their operations. And that's the key thesis we drive in the report. And the report talks firstly about what is the best practice. The good news is there's a lot of things that we can do as operators. We identified about 40 specific initiatives that could be undertaken, and they're categorized in these broad 5 categories. I will leave it to Danny and John to go into a bit more detail and give you more examples of the kind of initiatives that operators can put in place to drive best practice. And the good news is there's a lot of opportunity out there. You have to organize yourself, and you have to identify them, and you have to execute. So that's on that side. On the flip side, there's also good evidence that customers, both enterprise and consumers, really want to see more from their telcos in terms of their telcos' own carbon emissions, and they want to see evidence that the operators are committed to a zero carbon future, and that's across all the regions. And they want more best practice, and they really want the operators to be their own best case study when it comes to introducing greater operational effectiveness and driving this coordination age that we talked about earlier. So there is a desire for there's an expectation from enterprises, and we surveyed 500 of them globally, for operators to be doing more and bringing that knowledge, insight and learning and experience and credibility to them. So finally, to wrap up, to summarize, this was a very quick overview of the report. We are arguing that this is not, there are big challenges for 5G when it comes to energy, but those challenges should not be a constraint. Rather the opposite, they should be seen as an opportunity that operators can set the ambition, they can adopt best practice and be their best case study. So practice what they preach and preach what they practice. But that's an overview. Please download the report and read it through in more detail.
Great, thank you very much, Phil. Next up, we will hear from Danny Wong from Virtiv. Over to you, Danny.
Hi, good morning, good afternoon, everyone. I'm Danny, I'm from Virtiv. So the next few minutes, I'm going to walk you through some slides that will explain a little bit more on what actually happened in the ground, and also share with you some of the perspective of what do you mean by 5G deployment on a balancing act in how operators actually balance some of these to benefits. So just a quick glance on Virtiv. We are a global company that focuses in providing protections and enhancing solution for the critical for the infrastructure of the critical infrastructures facilities. We involve in design, build, and supply and some of these components to various industries. And one of the biggest industry that we are in actually the telecom industry. So we actually go into a lot, because of our experience of working with many of the customers, we actually develop a lot of solutions and by understanding their challenges. And here, the next few slides will share with you some of these practical experience that we have working with the operators in striking the balancing act. Next slide. So when we look at this BC slide, let's just put our attentions onto the right-hand side. And this is a survey that has been run out. And this is a survey coming from the operators, people in the industry. And this is what they rank as number 1, number 2, number 3, and what is most important for them when they are looking into communication products and services. But if you look at some part of all these things, and how do you tie back to the left-hand side? Now, the left-hand side is all about balancing act. You have an underlying 5G network to be deployed. Now, one of the things that we normally known from the 5G, from the mobile network perspective is a lot of time we look at deployment speed, we look at coverage, we look at capacities, we look at capital efficiency, we look at reliabilities, and these are not new in 5G as well. So in 5G domain, actually, these are some of the same characteristics that we and our customers and their customers are looking at from the performance perspective, or we call it cost plus performance. And we added in one whole row of sustainability. And why is so? So if we start to look back into 5G, first of all, 5G itself is enabling technologies. Like Phil mentioned earlier on, 5G is actually being seen as a technology that enable a lot of solutions to real world problems, resource problems, traffic problems, wastage problem, utilization problems. And secondly, 5G itself as a technology, it itself is actually a technology that incorporates a lot of sustainability design in its design. For example, also Phil pointed out early on, 5G doesn't really add power to if you just base it on a per megawatt transmission. But 5G actually transmit the same amount of data by just utilizing 10 to 15% of the energy required, which is highly efficient. Of course, that combined hardware and software features is highly efficient. But one part of the things that the operators is struggling to cope with in the first phase 1 and the phase 2 and the phase 3 of deployment for 5G is the last piece, which is the actual rollout of the 5G, which actually will take up a lot more power consumption because the total volume of data is increased, number 1. Number 2, we have to understand that 5G is not a standalone network, which means we tear down all the previous generation mobile networks and we just put a standalone 5G. No. So which means to operator perspective, 5G is added on top of their existing mobile networks. So this is an important piece of the sustainability thought process that we have to think about. So in this sense, I think if you look at the future growth, you look at efficiency and TCO and life cycle, some part of this thing is very contradicting between each other, especially when we compare to the cost, when we have a high coverage, of course, you have more cost, how do you strike efficiency? How do you balance your dollar and cent? How do you improve your capital efficiency? In the meantime, you have a better TCO, whatever. So this is the critical part that we personally believe, and we have been working with many of our customers, and this is something that we continue to strike, and hopefully that there's not mutually exclusive on some of these things. And this is very important, and I believe that Phil in his early slide already show you the opportunity behind this, and also, in other words, the threat behind it if we as an industry do not manage this well on a sustainable manner. Next slide. In this slide, Phil touched on it earlier on. So I'm going to give you some examples. There are a lot of examples. Actually, I just will share some of the example to you. So this is the 5 domain. For example, network technology. We all know that using more efficient network hardware is important, but one of the examples I'd like to put forward here is that using the efficient hardware itself might not be enough, but using the entire and encapsulate the entire, oh, sorry, back slide before. I think we jumped the slide a bit. So I'll continue on the slide.
Yeah.
Yes, this slide. Yeah, I think the slide is in the transition mode. So when we are looking into the transitions of the, already changed to this slide already. I think the slide before with the 5 column. It was a gentleman, is a late evening in Asia. Sorry for the hiccup. Is this seem to suffering one? A bit of transitions. Yeah, the slide before there was a 5 column. Yeah, yes, best practice. Yeah. So from the architecture perspective, if you are able to, we've seen operators are able to actually redesign the architectures, and this redesign of architecture manage to provide them with a more flexible use of the power efficient hardware. The result is even better. The result not only short term, but also result is more long term. This is also coupled with some software features in the network itself. I'll go down a bit more to share with you facility infrastructures. This is where our domain is, high performance cooling and power and cooling systems. One of the things that we will suggest that you should not be bothered on efficiency itself, the high performance itself, but look at it holistically. Is there any technology itself which is more powerful or more efficient than the other technology, and not just contained within? And we've seen that happening. Infrastructure management, we've seen operators actually incorporated management systems, monitoring systems across their network as part of the digital transformation process. And their saving is enormous. And the savings is actually 20% more than what they projected, not only from the resources, but also from the energy consumptions, and also because of availability of information, visibility of site condition, they are able to drive more optimization at the sites. Organization evaluation, this is very important. Now, what we discussed earlier on might make sense, but if you look at organization evaluation, one of the concrete examples I'd like to bring up here is we have a customer who has actually transitioned from a gel batteries to a lithium-ion battery since 2018. It is not an easy task because the internal organization will give you a lump sum budget and expected you to replace so many batteries on the field. But if you, with using the same budget, there's no way that you could replace all the sites. So it's a struggling act between the organization trying to balance the benefit of new technologies and also the number of sites they need to replace on the existing battery. But what they took a bold steps, they work with the finance teams and they took a bold step. What happened now is that 2020, 2021 now, this year they have budget. Same, every year they have budget for battery replacement, and this year the good thing is because they replaced some of the battery 2 years ago, and this battery is subject to replacement last year, but because of they changed the technology of the battery to lithium, their replacement cycle now is extended, so they do not need to replace every 2 years. Now they replace every 4 years now. So the budget that they are using for replacement last year is now using it for replacement of the battery into a new year as well, into other sites as well. So this is very important because when we look into this, you have to look into life cycles. And lastly, I think most of the time that being a telco, we always become a consumer. And it is important for us to look at, is there a way that we could become a prosumer by generating some of the electricity and that could pump back into the electric grid itself. Now, I'll move into two more detailed examples in the next couple of slides. So the first domain of the saving is the excess, saving in the excess. I think your slide will show up slowly. In this particular slide is that in this particular country, the energy cost is really relatively high, and the number we plug in here is just the average commercial rate. It's not even the peak rate. So when you have paying 30 cents per kilowatt hours, the operator face two challenges. Number one, with 5G is even going to be more. Yeah, as I mentioned earlier, 5G is on top of all the existing mobile technology. Secondly, energy availability will become a challenge. we just can't increase the power requirement at one side and expect the utility company to be able to provide that. It takes time and it costs more. So because of that, they have a long-term vision to improve this. They want to drive the efficiency by an estimated first phase of 4%, and also because they also want to improve the availability. The best thing to improve availability is we are optimizing the incoming by improving the conversions into the power that we require. So the solution is that they took a very bold step. They are one of the first in the region that actually heavily deploy 98% efficiency rectifiers. Now you see the end result, and the end result that we publish here is just 1 year of saving. 1 year of saving, and of course it takes time for all this site to be built up, and almost half of this site is transition from lower efficiency, and half of this site is transition from a 95, 96 efficiency. And if you look at that, this based on the 6,000 site, this is annual saving of $7 million, 23 gigawatt, and a big substantial amount of carbon footprint, 13.62 kiloton of carbon reduction. And this is just the first year. This is not even the total life cycle of the entire investment, which could last for average 8 to 10 years time periods of time. So this is a bold domain in the access. I will share another one in the news domain for 5G. The next slide, please. So in the next slide, in 5G is something new. In 5G is the edge. Even though in the past we still have some level of edge, depending on our definitions and classification, but in 5G the edge become more prominent, and everybody in 5G industry talk about edge, even the consumer levels as well. We know that we need to build edge. Operator knows that they need to build edge, and edge is very important for 5G on all the benefit that it can offer: low latencies, massive connectivity. But because of that, these particular operators understand that do not have the full visibility how an edge should be built. If you build a huge edge, you are actually wasting a lot of energy. Your utilization will be low if take-up rate is low. But if you build very compact edge sites that difficult to scale, you will have other challenges that go along with it, because every upgrade is a truckload upgrades, and you cannot leverage a lot of leveraging. You can't do. So because of that, they want to evaluate key technologies and architecture that is help them into every of this design perspective. So they look into the building block itself. How do I contain it? How do I use high capacity coolings? What are the smart control features that I need to have? So overall, as an end result, they're practically looking into evaluating across broader spectrum of technologies, and they, after evaluating the feasibility, they put all these things together and start to build, integrate it as the final solutions. And this final solution not only incorporate the best technology, but also incorporate the design factor that allow it to scale, allow more leveraging to be used on the investment that they have. And on the overall, because of this, actually, they found out that they're improving of PUE, which is in other words, another measurements, it's like the conventional measurements of how efficient a data center is on the mechanical load, the energy requires to cool down the data center compared to the utility that's actually power the servers and the network equipments. And in this particular case, I think we didn't put here, but the PUE is roughly at the range of 1.3 to 1.35, which is significantly lower than way they could build on a conventional manner. So whatever runs on the peak maximum there, these are the potential saving. There are saving on this network itself. Yeah. Next. So this is the last slide and the key takeaway, just summarizing a bit and also reinforcing a couple of things that I mentioned earlier on. 5G balancing act. It is nowhere that 5G can be deployed successfully if we do not consider the sustainability fact. And Phil and myself and a lot of the people in the industry are well aware of this. That's why for operators, this is very important part of a consideration how to achieve the balancing act. There are a lot more. We found that over the years that there are a lot more best practice in data centers, which I think some of these best practice are very usable and very applicable to the entire 5G network deployment, given that the introductions of the edge into the network. CapEx efficiency requirements is always there, but CapEx efficiency requirement is taken into the total consideration of the total cost of ownership that look into the replacement cycles, maintenance costs, and all those sort of things would be more important than just the CapEx efficiency itself. Network holistically, architecture and hardware actually make a big difference. Hardware changes actually make a big difference if the similar architecture can be deployed. So vice versa, if an architecture might require a different hardware piece that comes in that allow it to be efficient to be running. So this has to be looked holistically beyond just the hardware or beyond just the architecture. Scenario planning for balancing growth and first cost, and this has been mentioned early on. How do we balance the growth and the first cost, as pointed out by the previous examples? Prioritization of technology efficiency in point solution, and this is self-explanatory, quite intuitive enough when we start to prioritize the technologies and efficiencies into the products itself, into the underlying technologies itself, and that actually benefits is more critical and more substantial than when we're just looking into the technology or efficiency from just a solution alone. And lastly, we found that for 5G, it's important for operator to look at having a high volume custom and standard building block. The last example that I brought up is actually a very good example, because operators are working with technology vendors to evaluate every technology across the board, to understand the pros and cons of every technology has to offer, and then tailor to something that they could roll out and customize it in a way that well suited to their corporate visions and corporate requirement. And in this case, actually what they can do is that they can actually save costs by having a high volume of custom, and they also can replicate it across the deployments, unlike previous time that a lot of the decisions have been made on a regional levels and operation levels, or planning level making a planning decision, operation level making an operation perspective. I think I'll end here my presentations. Back to you, Ria.
Great, thank you very much, Danny. I'm aware of time, so we'll swiftly move on to the panel discussion. And I think we'll start with a question for you, John and Yusheng, because we're very keen to get China Mobile's perspective here. So the first question that I had for you are, what are the main energy management challenges that 5G has presented, and what has China Mobile's approach been in solving these challenges?
Thank you. Hi, everyone. I will answer this question for you. As we all know, 5G is leading to many society changes, such as accelerating economic growth, creating new opportunities in social development, providing new digital life experience, and building new cooperation model. However, there are many difficulties and challenges in 5G network construction, which need to be solved. Compared with 4G network, 5G network has high bandwidth, high data flow, and high frequency band, which requires high transmit power of wireless devices. More channels leading to power consumption increase. The power consumption of one 5G station is up to 5 kilowatts, which is 3 to 4 times than that of 4G devices. We have tested the power consumption of 5G wireless devices and found big difference in different stations. The average power is about 60% of the rated power, and the no load power is about 50% of the rated power. These differences greatly affect the station power supply configuration. If the power supply is not matched properly, the initial and operation cost will increase. For the base station with additional 5G network, the mains capacity, DC power supply capacity, power distribution switch capacity, and battery capacity is sufficient. So 90% of existing power systems need to be expanded, which is costly and time consuming. For new 5G base station, cost of site selection, mains access, and installation are very high, which accounts for over 90% of the total construction cost, except for high CapEx. High OpEx of 5G network is another challenge. According to our own network construction experience, 70% of OpEx comes from the infrastructure. Firstly, the space utilization of the base station is low and the rental cost is high. Rental cost for an outdoor station is 10,000 yuan per year, and for an indoor station is 20,000 yuan. Secondly, the energy efficiency is low and the electricity cost is high. Electricity cost for an outdoor station is 20,000 yuan per year, and for an indoor station is 400,000 yuan. Thirdly, fault analysis is difficult and loss of maintenance result in high cost. So we are considering how to control the OpEx in the 5G construction. In addition, a large number of micro base stations need to be deployed in complex scenarios such as streets, office buildings, urban villages, and subway for the needs of deep coverage of 5G. In these scenarios, the power supply quantity is hard to be ensured. The power supply of the communication equipment may be interrupted due to lighting strikes, line switching, voltage fluctuation, and impact load. Facing these problems of 5G base station, including high power consumption, difficult restructuring, long construction period, high OpEx, and poor network quantity, China Mobile proposes the concept of digitalized equipment, integrated system, and intelligent operation and maintenance, and use innovative power supply products to build 5G network. Thank you.
Great, thank you, John. I had another question, Matt, that I think focuses a bit more on some of the findings of our research. And it's one question I'm wondering, do you really think that, energy efficiency is a reason that stakeholders would actually take their business elsewhere? Will the main drivers not just remain quality of service and price?
Yeah, I mean, I think as you kind of mentioned, the reaction of stakeholders was one of the sort of central themes of the research paper. And I think, yeah, it's a really sort of important thing that you touch on because price and quality of service, they're always going to be key drivers, and we're definitely not pretending that that's going to change. And I think Danny alluded to this in his presentation, and what we're saying now is that there is now this third driver in sustainability that increasingly operators will need to actually consider. And obviously different people value different factors more or less depending on personal preference. But it's reaching a point, and we'll, as we move into the coordination age especially, where operators can't afford to neglect one of these three factors. I think with regards to the stakeholders, I think we're already seeing evidence of consumers making purchase decisions off the basis of a company's ESG record. And I think what we often forget is that employees ultimately are just a subset of consumers as well. And as there's sort of growing sentiment that within the consumer group for operators to take more action on sustainability issues, this will grow in employees as well. And ultimately, people want to work for a company that reflects their own personal values. So I think if operators don't act with regards to sustainability, then they might have some issues with regards to retainment and recruitment of new employees. And then ultimately, investors want employees and customers to be happy as well. And if they see that there's discontent in these two groups, then it's likely that they're going to be dissatisfied as well. So yeah, I think one of the key things that we're trying to get across in the paper, and Phil touched on it in his presentation, is that if you don't take account of sustainability issues, then there will be financial consequences for the reasons that I kind of just skipped over there. But yeah, the key thing that we're saying is that there is now this third factor. We're not saying that sustainability is overtaking price and quality of service at all, but there's now this third factor that the operators increasingly need to consider.
Great, thanks, Matt. And just one more question that I have for you, Danny, before we move on to the Q&A, is in your experience, what are the top 3 things that operators should do when they're rolling out 5G in order to maximize their energy efficiency and reduce emissions?
I think the top 3 for 4 things across my mind now. Number 1 is that introduce clean energy wherever possible. I think a lot of debate and a lot of too much academic discussions actually prohibits operators actually to move forward with clean energy. When I mention clean energy or optimized solution or even high efficiency products, is not solely from the perspective of just the solar and hybrids and some of those things, but energy can be introduced in a format of, for example, even within the product itself, this product might be more efficient than the other. Number 1. Number 2, there could be technology where are more efficient than this type of technology. So, for example, battery is a good battery itself is a good examples of technology differences that cause a lot of energy differences. I also see that people evaluating fuel cell solutions technologies, and even within the context of fuel cell technology, there are also certain fuel cell has a much more effective conversion rate on the natural gas or hydrogens into the desired energy. So first of all, for operators, it's important to actually set up and really introduce clean energy whenever possible into it, even if a small success or whatever. The second emphasis is it's always better to look into a total cost of ownership and not just the capex itself, not just OPEX itself. In terms of the lifespan of the solutions, in terms of the replacement cycle of the solution. The last piece is that I think it is important to define best practice and design concept within the organizations itself, so that this become a learning for the entire organization, so that the organization realize that by doing so, they actually save so much. So encourage those saving behavior and habits around all the employees within the operators is important, because most of the time, not trying to be chronicle here, but sometimes people was being organization being rewarded by more saving here and there in the dollar and cent, but lack of the recognitions that actually make on saving, adoption of new technologies and adoptions of most efficient things that actually provide a longer term saving to them. So this is just the 3 points I'd like to mention. Yeah.
Great, thanks, Danny. I think now we'll take some questions that we've had come in from the audience. And John, we have one I think that is kind of directed at you. So the question is, what lessons can be applied to coordinating more efficiency in other industries to improve energy use?
Okay, thanks for this question. There are some ways that can improve the energy efficiency. Firstly, the usage of solar energy. Now the cost of photovoltaic power in the life cycle is 3 to 5 cents per kilowatt hour, which is much less than the cost of the thermal power. In 5G age, solar energy will be widely used in communication field. By using intelligent management technology for photovoltaic power and mains power, the power control technology, the generating efficiency of solar energy can be improved and the green energy will be widely used, which is benefit for the society and the operating cost reduce. Secondly, change the indoor station into outdoor station. For indoor station, much power is consumed by the air conditioning, which leads to high energy consumption of the station. Energy efficiency of a typical station is about 60%. By changing the indoor station into outdoor station, energy efficiency can be improved to 85% to 90%. So the air conditioning energy consumption and OPEX can be reduced. Thirdly, inefficient power supply modification. Now there are lots of inefficient power supply with efficiency of 90% in the station. They can be substituted by the new power supply with the efficiency of 98%. So the power loss and OPEX can be reduced. Another way is cooperation management between subsystems. Cooperation management between AAU and the power supply can be adjusted the power voltage according to the AAU load to reduce the power loss. Cooperation management between power supply and the business can reduce the energy consumption per traffic according to the needs. By using AI, operating parameters can be adjusted according to the air temperature, humidity, energy condition, and business to maximize the system energy efficiency. Finally, equipment adjustment with business. The data flow of communication network is fluctuant with the time. By short the channel, signal carrier, and frequency band, the no load loss of the wireless equipment can be reduced, which leads to 10% to 20% energy saving. Thank you.
Thanks, John. And Matt, we have a question that I think kind of follows up on what you were saying about the different motives for stakeholders. And I guess the question is, does that question hold true across all regions, or have you seen that there are kind of regional differences there?
Mm-hmm. Yeah, I mean, I think of course there are regional differences, and we did try to reflect this in the research paper as well. And I guess this is for all sorts of reasons, really. Different levels of development, different energy markets, and even just sort of different levels of environmental consciousness, like within a country's society. And I think there are of course going to be some operators who are fortunate enough to be in markets where maybe there's an abundance of renewable energy, such as hydropower or geothermal, or perhaps the government has massively invested in wind or solar. But this doesn't mean that the operators that are less fortunate and that are in countries that have maybe a very carbon intensive grid, or a government that isn't that acquiescent to sort of sustainability issues. But this doesn't mean that those operators can't take the lead. And I think if anything, it means that the marginal benefit that they would experience from implementing some of the kind of practical advice that Danny ran through is going to be larger. I mean, if we just look at an example, in terms of on-site renewable energy generation, obviously any operator that takes this on in a country where their grid is particularly dirty and carbon intensive, they're going to reduce their carbon emissions by switching to on-site renewables. But I think the point is that in a lot of countries, the grid will be particularly unreliable as well. So in switching to this on-site renewable generation where you can, not only are you going to reduce your carbon emissions, but you're also hopefully going to increase the reliability of the network. And this moves more towards the kind of balancing act that Danny kind of mentioned. And I think the other point is that while governments and public infrastructure might lag behind in terms of sustainability and adherence to sort of global sustainability quotas and things like that, this doesn't mean that the stakeholders in this country will have expectations that are particularly low as well. I think consumers and employees will look to other countries and see the kind of global efforts that are being made and want the operator in their country to kind of take the lead as well. And then obviously investors will kind of follow off the back of that. But I think the practical advice applies across all regions, and certainly the kind of advice and the recommendations that we give to leadership can do as well. But I think operators can apply learnings across countries really, and yeah, there's definitely benefits to be had in all regions, and yeah, I think the stakeholder argument definitely holds in all countries.
Great, thanks, Matt. And Phil, we've had a question come through from Widodi that I think I'll give to you, and that is, what edge do you recommend to strengthen 5G?
Yeah, I mean, actually, I'm going to echo, well, I'm just going to maybe repeat what John said. I think what John said, that one of the findings that they've had in deploying 5G is that outdoor stations, I think you were saying, John, that the smaller closed cabinets have proved more efficient from an energy and from an OPEX perspective than indoor stations. Is that correct? You were saying that the outdoor stations you were finding those significantly improved performance because of free cooling and because of lower capex and deployment costs. I think that's what you were saying, John. So I don't know if that quite answers Dodi's question, but I think the experience from China Mobile is smaller edge deployments, smaller outdoor edge deployments are proving more effective from an energy management perspective, or from keeping the cost down and keeping the energy down. That's what I heard from John. But that's not my recommendation. It's me interpreting what we've already heard today.
Great, thank you, Phil. Another question that I think I'll give to you, Matt, is a lot of operators won't be near to even rolling out 5G. So is this actually relevant to them as well?
Mm-hmm. Yeah, I mean, definitely. I think, while 5G has new challenges and new opportunities with regards to energy, as both Phil and Danny kind of touched on in their presentations, I think in many ways, lots of the challenges are the same as they are with sort of previous iterations of mobile technology, and these will be hanging over the heads of all operators, really. I mean, even if we just look at the data traffic volume slide that Phil ran us through, these have been increasing for several years now, predating any sort of 5G deployment. And this is going to continue for the next few years as well, even for 2, 3, and 4G. So even in markets without access to 5G, we're going to be moving to the coordination age. More and more devices are going to be connected, and we'll see these data traffic volumes increase. So 2, 3, and 4G networks can definitely be run more efficiently than they currently are. And this is going to reduce costs for operators as well. So it's not just a question of trying to appease people that are shouting loudest about sustainability issues. You're reducing your costs as well. So it's a sensible business decision to try and implement some of this advice for 2, 3, and 4G. So the practical advice definitely applies, and lots of it does anyway. And I think the kind of top-down advice to leadership definitely counts as well. So applying these objectives right at the very top at the group level, implementing bonus schemes that kind of reflect this, trying to adjust departmental budgets as well. And if you implement some of these recommendations in the short term, it saves you costs and probably an element of social credit as well. But then in the medium to longer term, it's going to prepare you for 5G and the kind of challenges that this brings as well. So yes, definitely, I think most of the recommendations in the paper will apply to all operators, regardless of where they are on their kind of 5G deployment roadmap.
Great. Thanks, Matt. And another question that we've had from Daniel, Phil or Danny, I don't know if one of you would like to take this. He says, is the statement regarding 5G and 4G capacity being equal by 2027 a global one? He said, I can imagine a lot of densely populated areas being reliant primarily on 4G. Perhaps, Phil, you could take that question.
Yeah, that projection is global. Obviously, some countries will be moving faster than others. So a lot of countries have already deployed 5G. Clearly, they're ahead. I think there are some countries in the world that are already over 30% of the traffic is on 5G, some of the earlier adopters. So they will be, way ahead of the curve. And there are some countries that haven't launched yet. There are some countries that have barely launched 4G. So yes, that is a global view. And I think actually I would slightly disagree with Daniel's hypothesis here. I think the most densely populated geos will be is where you're going to see the first 5G coverage, and 5G coverage to less densely populated will come later. So I think 4G will probably play a longer role, a stronger role in sort of suburban and semi-rural environments because of the cell density that makes it more financially challenging to bring that coverage. But yes, it's a global projection, and I think it's very similar to projections that others have produced. So probably our projection is a little more aggressive, but it's very comparable to other common market projections.
Great, thanks, Phil. And I'm aware we've only got 5 minutes left, but Danny, I actually had a question for you just based on conversations that we've had before, where you've mentioned that there are cases where the teams who are responsible for facility maintenance have actually been adopting domestic aircon units because they're cheaper and easier to maintain locally, but obviously result in a higher overall TCO. And they would benefit from kind of adopting a more holistic approach to energy. So do you mind just in these last few minutes telling us a little bit more about these kind of energy opportunities and how operators can go about addressing them?
Oh, okay, sure. I think there are two contexts towards this. Some of those already mentioned by John. The first context is that the design is not optimized. So from the design perspective, it's not right, which means we actually using aircon to cool the environment, or we are not supposed to use the aircon to cool the air for the air supply into the equipment, or to cool the battery to provide an ambient temperature which is suitable for the battery, which is 20 to 25 degrees Celsius. But instead of that, we actually cool the entire room, which is good for the engineer to work and all those things. But most of the time, actually, we are spending money there. So from the design philosophy, it's not right. It's like a freezer, you know. The freezer is only used for frozen up thing. Imagine if we open up our freezer and our fridge, we are paying a lot more energy cost. And at the end of the day, we are not only that we are paying a lot of money, but we are not able to cool the things. We are not able to frozen my ice cube and all those stuff. Yeah, number one. Number two is the product itself selections. A lot of people are using comfort aircon because it's easy. It's just few $100 and plus a couple of $100 of installation fees. That is it. If the one is not enough, I buy two. If two is not enough, I buy three, and I buy additional N+1 just to make it rotate, you know, using thermostat or whatever. But one of the things the people don't realize is that, yes, the capex might be cheaper, but the efficiency of the comfort aircon is really, really low, because comfort aircon actually use up 30% of the input power to actually compensate for the humidity. Because as human, we need humidity. So in other words, 1 kilowatt of load that we power on the aircon, actually 30% or 25% of those actually used to control the humidity, and only the 75% of those used to cool down the place. But compared to precision aircon that is specifically designed to cool equipment, 90% of the cooling efficiency is actually onto the cooling part. It's nothing to do with the humidity. So because of that contrast difference, you can see that some site, if they are actually changing some model of this, they are able to actually save 60 to 70% from the design, and also combined with the products itself. Yeah.
So that's really about more holistic thinking. If you look too narrowly at the capex, you'll end up, yes, buying a cheaper consumer air conditioning unit, but over the life cycle, you'll end up consuming vastly more amounts of energy. So there's a disconnect between the teams who are responsible for managing the facility and commissioning the local and the overall bill that's being paid, perhaps more centrally in the organization. So you have to bring those parts together for a TCO vision. And that takes a bit of thinking through and a bit more coordination and a bit more focus around energy within the company.
Absolutely.
Great. Well, unfortunately, we are out of time. And so I just wanted to say thank you to all of our presenters and panelists, and thank you to our audience who have joined in the conversation. Thanks as well to Virtiv, who have sponsored this research and the webinar. And just a reminder to all of the audience that we will be sharing the recording and presentation slides, as well as responses to any unanswered questions following the session. So thank you, everybody, and goodbye.
Thanks, Ria.
Thank you.
Thanks, Danny. Thanks, John.
Thank
Thanks for
you.
sharing. Cheers. Bye, man. Bye.